We have an example problem here. A vertical spring with a spring constant of 2 newtons per meter has a 0.3 kilogram mass attached to it, and the mass moves in a medium with a damping constant of 0.025 kilograms per second. The mass is released from rest at a position 5 centimeters from the equilibrium position. How long will it take for the amplitude to decrease to 4.5 centimeters? All right, so vertical spring, oh, that's not a very nice picture. It's oscillating up and down. The mass is released from rest at a position of 5 centimeters from equilibrium. So that's our A naught. That's the initial amplitude. They give us the spring constant, 2 newtons per meter, the mass, 0.3 kilograms, the damping constant, 0.025 kilograms per second. Mass released from rest at a position 5 centimeters from equilibrium. How long will it take for the amplitude to decrease to 4.5 centimeters? Okay, so it's asking us about how the amplitude is changing. Now, as a reminder, with damped oscillations, we have a couple of equations. This equation, the x of t, represents the position of the oscillator, the mass in this case, as a function of time. So exactly where the mass would be located at any given moment in time. This portion represents how the amplitude itself is changing with time. So not where the mass is specifically, but just how that amplitude is decreasing and dying off with time. All right, so since this problem is asking us about how the amplitude is changing, we specifically only need to look at this amplitude as a function of time equation. So A naught, we know, is 5 centimeters. We're trying to find the time at which the amplitude is 4.5 centimeters. We know B, we know M, so T is our only unknown. To get the power out of the exponential function, we can take the natural log, but divide by this 5 centimeters first to have the exponential function by itself. Now notice the centimeters cancel. So I have 4.5 over 5 is e to the negative bt over 2m. Now is when I can take the natural log of both sides to get rid of the exponential. So the natural log of 4.5 over 5 is going to equal negative bt over 2m. We're looking for the time, so I can bring the 2m over b and multiply that over. So the mass in this case, the 0.3 kilograms, b 0.025 kilograms per second times the natural log. These kilograms are going to cancel, and we're going to end up with units of seconds, which is good because we are looking for a time. So plugging these numbers in, I'm getting 2.5287, so forth. Coming back to the problem, I have two sig figs, so 2.5 seconds. I'm going to write that out a little bit because my 5 and my S look very similar there. So 2.5 seconds for the amplitude to decrease to 4.5 centimeters.